Posture is the way our body is oriented with respect to the force of gravity. Having good posture means that there's an even distribution of the force of gravity throughout our body and that no part is being strained or overstressed. Aside from making us look confident, a good posture is also beneficial to our health as it improves our breathing, circulation, and digestion. It also keeps our muscles, bones, joints, and spine in the correct alignment. It can also contribute to our frame of mind. Now, let us take a look at this adaptive wearable smart fabric developed by Durbhaka, Kanakandadi, and Danyam Rahu of HCL Technologies Ltd. The adaptive wearable smart fabric is composed of sensors, a processor, and an air diaphragm. Sensors incorporated in this fabric are load, accelerometer, and pulse sensors. These sensors are placed in different parts of the fabric for full identification of the user's posture and movement. Data acquired from the sensors are then processed via a processor using an analytical model based on the principles of adaptive resonance theory. The posture of the user is determined in this step. An aerodynamic equilibrium is maintained via inflation or deflation of an air diaphragm that is placed within the fabric. The air diaphragm is powered by our chargeable battery. Adaptive resonance theory, or ART, was developed by Carpenter and Grossberg of Boston University. ART is a matching process that compares an external input with the internal memory of an active code. This theory is based on match-based learning and error-based learning, where memories of a system are retained or changed in response to matches or mismatches to reduce the differences between the target and actual output. Upon receiving information from the external environment, the processor analyzes the data and conducts a parallel memory search and has two possible responses. If the input matches an established code, the same memory is represented and new information is incorporated to further expand this memory. If the input is presumed to be a new code, the input is now stored to the processor's memory, and the processor performs fast learning by adapting to the external environment to generate a response. The flow chart is an example of a stored code for the smart fabric. This smart fabric responds to the user's body temperature and posture change to help the user gain more comfort and maintain a good posture. Durbhaka and his team were able to conduct initial tests for the smart fabric using an accelerometer sensor. They were able to identify sitting and sleeping positions and respond by providing a dynamic airflow via a decision support system. They reported a classification accuracy of approximately 87%. The inventors filed a patent application for the adaptive wearable smart fabric in 2016. The patent described the design and science behind the invention. The adaptive wearable smart fabric was initially modeled for medical applications, but now it can also be used in sports. Rifle shooting is an example of a sport that requires a very good stance. To ensure that the shooters have a perfect position at all times, they wear shooting jackets and trousers over their day-to-day clothes. To be honest, these gear are quite heavy and are not very suitable for the Philippine climate. We can apply the technology of the smart fabric to make shooting gear that are lightweight and comfortable. This technology can also be applied to the environment. Using the sensors, processors, and principles of the adaptive resonance theory, we can have controlled greenhouses that can house our crops and plants.